आज के इस वीडियो में हम लोग रेनफोर्स्ड स्टील के बारे में पढ़ेंगे। वी नो दैट ऑल द सिविल इंजीनियरिंग स्ट्रक्चर विच आर बिल्ट, चाहे वो ब्रिजेज हो, बिल्डिंग्स हो, इंडस्ट्रियल स्ट्रक्चर हो, सभी जगह कंक्रीट का यूटिलाइजेशन होता है। इस कंक्रीट का यूटिलाइजेशन जहाँ भी होगा वहाँ स्टील का यूटिलाइजेशन होगा ही, इसलिए कंबाइंड टर्म रेनफोर्स्ड सीमेंट कंक्रीट इसके लिए यूज किया जाता है। वी नो दैट concrete is very strong in compression but very weak in tension. लगभग इसका टेंसाइल स्ट्रेंथ कंप्रेसिव स्ट्रेंथ का 1/10 होता है। इसी टेंसाइल स्ट्रेंथ को इम्प्रूव करने के लिए वी यूज द स्टील इन कंक्रीट। नाउ चूंकि इसका थर्मल कोफिशिएंट स्टील का और कंक्रीट का बराबर होता है, इसलिए बहुत अच्छे से एक दूसरे के साथ में काम करते हैं और कंक्रीट के स्ट्रेंथ को, टेंसाइल स्ट्रेंथ को इम्प्रूव करते हैं। आज के इस वीडियो में इंट्रोडक्टरी पार्ट का हम लोग अध्ययन करेंगे। उसके बाद में कैसे स्टील को फिजिकल टेस्ट कैरी होते हैं, कैसे केमिकल टेस्ट कैरी किए जाते हैं, उनका कितना परमिसिबल लिमिट्स हैं, उसको स्टडी करेंगे। हाउ बार बेंडिंग रूल्स आर बीइंग मेड फॉर कंस्ट्रक्शन, बहुत सारी चीज़ों को कैसे बेंडिंग किया जाता है, कौन सी मशीनें यूज की जाती हैं बेंडिंग में, किस तरह के स्किल सेट लगेंगे, इसके बारे में डिटेल में आने वाले वीडियोज में हम लोग स्टडी करेंगे। सो टुडे वी विल स्टार्ट इंट्रोडक्टरी पार्ट ऑफ द reinforced steel. Popularly it is known as a rebar. So जो कोड, प्राइमरीली जो कोड होते हैं इसके IS कोड जो है, एक है 5525, it was published in 1969. Then second है IS SP 34 1987. Third IS 1786, it was 2008-2018. Likewise, there are for shape we use IS 2502. For physical test we use IS 1608. For chemical test we use IS 228. For bend driven test we use IS 1599. There are many more. Basically this 6 IS code gives most of the detail, so we can go with the basically 5525, 34, 1786. All we will study and require, and we will add more. In IS 5525 रीबार के सिंबल्स दिए हुए हैं कि रीबार के, ये जो प्लेन रीबार है उसको 5 से, प्लेन 5 से, ये स्क्वायर रीबार है तो सिंबल विल बी स्क्वायर फॉर स्क्वायर रीबार. And for the deformed rebar, deformed steel which is being used in today, it will be hatch like symbol. So we will be using hatch symbol for the deformed steel. When we have to write say plain bar of 10 mm, so we need to write 510. Generally in practice we write 10-5, which is wrong. We should write as per code 510, like square bar square 10, and for the deformed bar hatch 10. Number will come in front. Like if this bar of 5 number is to be used, then 5, 10, 5. This is how it is being used in the preparation of drawings, structural drawings. Now IS 34 1987 gives the formula how to get the equivalent dia of the deformed bar, because deformed bar को मेजर करके इक्विवेलेंसी डाया नहीं मिल पाता है, इसके लिए इसको प्लेन बार के इक्विवेलेंट में वेट लेते हैं और उसका इनडायरेक्ट मेथड से उसका डाया अराइव करते हैं। एक कोई स्टील बार हमको फील्ड में मिल जाती है, तो हाउ टू वी फाइंड आउट how much dia it is? We generally say it is 10 mm, 20 mm, but there is a formula to get it. So up to 0.5 meter minimum length of deformed bar deformed steel should be 0.5 meter. So formula for getting the diameter of bar is root 162.13 upon L into weight W. We should take preferably 1 meter bar, deformed bar, cut it to a size of say 1 meter, 1 meter exactly. Variation is allowed, say 5.5% variation is allowed, but we must try to cut it as exact as possible, and then measure the weight, put the value of weight here, and the length, since it is 1 meter, value will be 1, so 5 will be known of the deformed bar. Generally we use deformed steel only. So IS 1786 gives the specification what kind of deformed steels are available and what is their strength. So IS 1786, as per IS 1786, bar are FE, FE, FE 415, FE 500, FE 550, and FE 600. In this there will be 415D, FE 5415D, and FE, this is category 415. Yes. So generally nowadays FE 550D is being used in the field. FE, we know that it is ferrous, and 415 is yield stress at 0.2% proof stress in Newton per mm square. If we find the yield stress of specimen, say Fe 415 10 mm, then we must draw the 0.2% proof stress and find out the offset of yield. That will be represented in Newton per meter square, mm square. We will be studying this in detail in coming up videos. Another question is, once we have the steel bars in the field at site, so how to get per meter weight of it? The engineers are using d square upon 162. How the d square upon 162 is arrived? We'll solve the question here. So we know that weight is density into volume. In IS 1786, the density is given. Density of steel is varying from 7850 to 8050. But in IS 1786, it has given that for all calculation purpose, density should be taken. Density of steel should be taken 7850 0.50 kg per meter cube. So, and since it is a rod is circular, so cross sectional area will be pi by 4 into d square. So let us input to get the weight of steel, weight of 1 meter steel, 1 meter length steel. Weight is density is 7850 into volume is pi by 4 upon into d square into 1 meter. So weight will be 7850 into pi by 4, 0.785. Since let us convert d into meter. So d upon 1000 into whole square into 1. So weight W will be 1000 into 1000, simplifying it, equal to 7850 into 0.785 d square. So d square will be W into 1000 upon 7850 into 0.785. If we solve this, 1000000 divide by 7850 divide by 0.785 equal to 162.27. So it will be 162.27 W. So W. So weight per meter will be d square upon 162.27, simplifying it for the field calculation purpose, d square divided by 162, where d will be in the millimeter. So let us take up the question. 8 mm. 8 mm tar steel or deformed steel will be 8 square upon 162. So let us calculate it. 8 square is nothing but 64 divided by 162 equal to 0.395. 0.395. Likewise, if we take 20 mm deformed steel, so it will be W will be 20 into 20 divided by 162. So 400 divided by 162, which will be equal to 400 divided by 162 is equal to 2.469. So equal to 2.469, nothing but 2.47 kgs. So weight per meter of 8 mm steel we found 0.395 and weight of 20 mm steel 2.47 kg per meter. So likewise in the field, once we know the dia of steel, we can find out weight per meter of the steel, which is very useful in making the bar building schedule and estimating the quantities of steel. Thanking you. We will be taking up more videos in coming. Thank you.